Ya, poquito.
I'm gonna, find your restroom and get me a bottle of water. All right, so that's gonna come up as, CWC with.
Oh.
So it says the postal elections. You know, the video, you see the
Mm-hmm.
video of, and then we'll. So, I don't know what happens if we make. Well, let's. No, we want to give you, we want to give this one more properties. So let's see. All right, let me see if I can start sharing
Okay.
on here. Yeah, that controls that camera there. This is what we're.
Well, hold on.
No, y'all finish it.
Yeah,
Don't y'all finish.
I mean, what it can do is, I mean, it can make the camera move around and like maybe see other parts, but I mean, right now it's, you know, it's kind of focused on here, which is probably,
Yes.
Well, but see, we got a flip on it. You see my hand? You see? So we-
yeah. Well, yeah.
I'm just saying.
You gonna figure it out.
Well,
Don't.
all right, I think I need to do this. Let's try that. That. So now we're seeing the, you know,
Mhm.
we're seeing the PowerPoints, but what you're telling me is that we've had in the past where,
You could see, like I could see very.
right, like up close, yeah.
Uh-huh.
All right, so there's gotta be a way to do that.
Where'd you get that water from?
So is that how we usually, we have the
Mhm.
infinity thing going on?
Mhm.
No, not that. But we usually just pretty much like that.
Yeah.
And usually, you know, those in the, around here. You know,
So,
this arrow's doing.
and then basically, so,
That look better.
so. So what we're doing is that this share is in the advance. And it's content from second camera. So that's bringing in that thing. we're looking at. And then we want to get back to the PowerPoint. We gotta go here to the basic. Click on the PowerPoint and show that. Now we're looking at the PowerPoint.
I'm not gonna be long, I'm just gonna come to the office. So wait a few, 15 minutes, I got in there. I'll be in.
Do you have met a lot of people that come in person or most of them in the most?
Well, most of them are right now. They'll be on there. We've been there.
Just a heads up, I'm gonna have to bug out pretty quick because I got another meeting.
That's what he said.
I gotta be in the shy at 7 o'clock.
PM. I had just get it.
So that's all right. I can do that.
I was, like I said, I didn't push hard birthday.
I appreciate it. I mean, I can make it easy if you pick the time
We will,
roughly.
we will, yeah. I usually, no.
So who's got after me? Is that you? Come up?
Yeah, that's me. I'm gonna. I'll be around beach. I'll food call. Back off and got him. I'll be. That's what I want.
Well, yeah, everything's on mine. Is on the certified test.
Yeah.
And the next one up also.
Some.
Yeah, that, did you hear about the advanced, school in Wilson?
Yeah.
2-day thing.
Yeah, I wasn't able to do it. Over here.
Oh, did you?
It's anywhere. And, I went around there. I'm going from there, Saturday.
Right. Yeah, I was there on Friday. Bridget, from Hickory was there on Saturday.
Coming on the second, right? Second June. Something.
Yeah, it was well attended. I guess they had like 25 people there.
I had a dental appointment that Friday, that's why we're going. talk to,
Oh, yeah.
and I told him I was. I wound up with a devil form, and I told myself, well, I'll be in Green. And I was hoping I was gonna be in Lincoln, but by the time we got to pull them out, put them in, pull them out, put them in,
Right.
well, this is good. But no,
Yeah, they went from a little club to right beside them in a couple of years.
I met some guys over there.
Yeah. And Greg, you know, Greg Wilbur moved.
Okay.
Greg Wilbur, well, Wilbur moved. Greg,
I think, yeah.
he's a timber guy from Nashville. He used to be very active in Five County. He's come down to Wilson, so he's about equal distance between the two, but might be a little close. So he's helping them out.
That's good.
Somebody's done it before, kind of thing.
Gotta have some color.
Yeah.
Walking off the streets and.
Yeah.
You look at the charter, you look at all the stuff on.
A lot of new ones start up and then they fizzle out pretty quick. Gotta keep it going.
We got a good thing going.
Right.
And
Yeah,
and they got 2 or 3 times now.
right,
Some of them.
right.
And so we work in, Zoom and everything. Like you certified.
Yeah.
That's like, people talk about, we're about to be a law. You got something going on. It can always be active. Talk to me, reason to talk to me. Because they get fascinated by me.
Right.
Well, you don't take it to a bad. They'll be all right. The lawyer will get some.
Right.
Like that.
Right.
I've been pretty good. I love it that. Yeah, you gotta have to figure out.
Yeah,
In the
that's
same building.
a challenge. Still help out with the group there at out from Canita, the family. Yeah, that's what. No, no more.
Been
The
years.
boys.
I'm doing a Christmas sector. Bees and pollination of small farmers on. Pollination. Small farm. Really neat. More produce.
Oh,
If he
yeah,
wants to compete.
sure.
You might want to strawberry, you might not even have a strawberry.
So,
Okay.
How we doing?
Oh,
Yeah,
is this,
this is the main one.
This is the main one.
if there's any,
There you go.
In the last 2 years, I'm telling you, it's been all electronic.
Everybody tell them.
Yeah.
They just got more Google Drive, just to show me how she can put this stuff in my drive, and I can go in there and if she got it.
You can do it. You can
Ask
do
them
it.
an email.
Oh, yeah, you can do it. You can do it.
256.
I got, And Michael's on in here, so anything you say is gonna have to do, 'cause I hear myself. just laughing.
Little feedback there.
Oh, it's a mute
All
your-
right, yeah, I'm gonna. Well, I didn't mute myself, that was.
Check.
Logan, can you hear us now? Yeah, I heard me back there. Okay, yes, okay. Feedback, yeah. Let me see. What I can do.
We ready?
Okay.
You just have the mic on just one.
My mom's here as well. Let me put this,
In other words, if I'm standing up there, they're gonna have to hear it through your laptop or no?
I have no idea. Now, can you hear me? Can you hear me? Can you hear me? Hold on, wait a minute. Can you hear me now? I know that's, I put the phone on mute while I said, can you hear me now? Okay. Yeah, I'm sharing the screen with, Chip, with NCWC. So I'm sharing it with him. I'm just trying to see what in the world.
Lined up the quarters and started shooting. I'm just lucky to be alive, the others weren't.
I'm trying to look through here and see what. Say that again. Uh-huh. So we got the NCWC Lib is the one that we got up and going. All right. And it's kind of crazy because what I did was I sent the information to Chip. And so Chip logged in, and so it's not my computer, it's the library computer. So he's, yeah. So that's what we're on. I'm doing too many things at one time. I guess you're supposed to be seeing, I don't know, what are you seeing? Because there's the microphone, he's got something else up there. Uh-huh.
Okay. All right.
We'll figure it out.
Yes, so I mean, but, because there's a problem with the audio before, is that the question? But you guys can hear us okay?
It's coming, it's coming. Okay, babe. Look, you know.
You got 10 minutes.
Waiting room 1, admit. I really like the putting down the hey. Well, we worded it real good.
Recording in progress.
So let's see, I need to stay. Okay, sounds good to me.
But if people say they can't hear it,
Can y'all hear now? Can y'all hear now? Hey, Logan, can y'all hear? Ooh, Logan. Okay, okay.
Hello.
Hey, everyone. We're just doing finishing up some technicalities on this side, and you will be seeing Mr. Berry, and he will be introducing our special guest in just a little bit. Give us about a couple of minutes.
A couple of minutes.
I mean, okay, so Barry, when you're ready to start, you start. Barry, you can start.
All right. Good evening, everybody. Good evening. Good. As many folks as we can get here. And welcome today. This session for me today. We do have a guest speaker. And it brought some new things to my mind that I knew, but I took for granted that everybody knew. And that was the importance of honeybees. The economic condition here in North Carolina and how big an industry it is and all that. And this class today kind of brings that about because most of the kids find out that they do in the school that state insect, the honeybee, stuff like that. They find that out, but they don't, we just don't get the reality of the depth of this thing. Well, there's a whole organization, agriculture in North Carolina. Agriculture and agriculture go hand in glove. And I noticed today, a gentleman is saying, he said, "Yeah, bee inspectors? Somebody got to inspect bees?" So basically things like that. But there's a whole organization of there's people that sell queens, they raise queens. There are people that sell other bee products. It's not just honey, but beeswax, pollen, crop pollination, especially crop pollination. That's one of the main areas that I'm involved in, especially when it comes to small farmers. We're not getting any new land, but one of the things about is that bringing in pollination, bees help increase your crop size, your production, especially strawberries, watermelons, cucumbers, and all those things like that. Well, now that we got all of this, we run into another problem. There's other diseases, stuff like that that come along. Somebody needs to look at bees, especially with buying bees from different places, different people. Get, different diseases, things like that we pick up. Well, the state got sort of like the bee health inspectors. We call them under the North Carolina Department of Agriculture and Community Services. We have the state apiary inspector. That's who I brought in today. One for our area. But anyway, I brought a gentleman today, and I'm not gonna hold it up much longer because I want him to talk to you about something, and which is very important. And this is Mr. Adolphus Leonard. Gonna come forward. He's the North Carolina State Beekeepers inspector. I'm letting him finish off on that and work his way right into what he's doing. You got Adolphus Leonard.
thank you.
Welcome.
Glad to be here. Maybe I'll just kick off since you said something about the apiary program. Our title is apiary inspector, but we do a lot more than just inspect bees. We, of course, we issue health certificates, so when you buy bees, you don't have to worry about buying disease. We also inspect colonies for disease and help to produce, come up with solutions to manage the bee problem, disease bee problem. And basically, we're kind of like fill in for extension. If you have a question about bees, we're also charged with promoting honey. So we try to help to get beekeepers. But the topic today is the honey. So why don't I just jump right into the slideshow? And, I like looking at pictures. I hope you do too. is one is island disease and pests and disease of brood, disease of adults, parasites and predators. I'm gonna have to get used to this fancy. When I teach people to recognize diseases, that are familiar with what healthy looks like. You know what a healthy condition is, then when it's different, you at least know that something's wrong. And you take a step further and you can try to identify what's wrong based on the symptoms, which are usually visualized by looking at brood or adults. This is normal brood development, starting from about 24-hour-old larvae, going all the way up to
Don't feel bad, that's me, that's the long time.
24 hours old to 21 days old, and adult be ready to go to work. That's normal healthy development.
So, yeah, you kind of slide it like this.
You gotta go the other way. There you go.
That's what a healthy egg looks like. When the queen lays an egg, she has one for each cell, and the first leg is excluded from the cell. So, sometimes they're hard to see, especially on the background. Over here, you see eggs inside the cell, freshly laid, because they're, you can tell they're freshly laid, because they're still standing up. You lay one egg at a time, exclude the bottom, and then as the egg ages over a 3-day period, it lies down in the cell, and then they, worker bees, the nurse bees feed, and then the larva takes off. That's another look at healthy egg. You see a dozen eggs in one cell, you know you got a problem, something wrong. You see 2 eggs in a cell once in a while, man, maybe you do, maybe you don't. See this is normal. And then after the egg lays down in the cell, first bees come along and they give it this little of larval food. And the developing larva takes up food through its skin. And that's how it feeds through its body. Later stage larvae, they're supposed to be white and plump. If you take a close look at it, you can see little convolution folds. Photography doesn't do this justice because you're getting a lot of the color of the root bone and not the color of the bees. It's a little more accurate color. That's a little better photograph to show you what.
What's that slide before, like ultrasound? So it's like this.
It's flat now, and it is from the top. The cone was cut like this. And this is looking for the front and what cell is intact. You can see little serrations or convolutions, and that's just a normal healthy growing. Any growth will be there. Just to summarize what we talked about, you know, an egg looks like a grain of rice when it's first laid, looks at the bottom, and you're looking for one per cell. Am I going the wrong way yet? Here's what a sealed, after the larva develops and it's time for the cell to be sealed, you're looking at a healthy sealed frame over here. So you got medium brown, the top of the cell is convex over, not flat, not sunken in. You see occasional mid spots, but not that many. That is a healthy frame brood. Frame brood, you got some older larvae here that will soon be capped over. This is the time of periods where they get capped, healthy, develop and work between the drones. They're capped after 5.5 for the queen, 6 and 6.5 days respectively for the workers and the drone. So somewhere along in that 5.5 to 6 day period, that's when the developing larvae getting filled over and metamorphosized from larval stage to pupil looks like. These are in the later stages. You can see limbs and eyes and head. That's normal and pretty light color. Why? Just reiterating that the brood cabins are medium round and around the on top, not flat, not sunken in. Then, they reaches its normal development at 21 days. The workers, it's going to chew the top off the cabin from the inside out. And this is it. So basically, it hatches. Now it's good. Baby chick taking its way out of this baby chick. And here are healthy adult babies. You got them fully formed, they're not deformed in any way. They got healthy wings, and the wings are not disjointed. Adult honeybees have 4 wings. They have 2 pairs that are normally put together, so it looks like a single wing. But sometimes when they get ill, they get sick, they'll unhook their wings, and that's called caving. These are healthy bees. They're not, well, I should say they're not shiny because they have these tiny hairs all over their body, and that gives them a matte appearance, not a shiny. If they look exceptionally shiny, I'm not talking about the light reflected off the skin, I'm talking about the bottom. So that means that the hair is missing or something happened to it. What makes a honeybee that different pollinator or is collecting nectar or pollen is in its hair, because it's a flower, it's going to get pollen on its body, regardless of what it's collecting. When it goes to the next flower, it's going to transfer that pollen, which is no part of the flower. It's no part of the flower, and that's pollination. That's how plants can produce. That's just a recap of what we're talking about. Eggs long, they're curly white in front, cap roots, medium round, convex, and adults have an overall healthy appearance. Iridescent wings, meaning that they reflect sunlight. They usually fold it when they're not flying. Now let's look at some of these brood diseases and make this healthy brood not appear to healthy. This is American foul brood. It's caused of agent from American foul brood. Aenomycillus larvae, that's a bacterium. And it's a spore-forming bacterium. It affects honeybee.
Check, check. Testing 2, 3.
All right, so I'll,
All right.
Let me mute this one. Sorry.
You're gonna have to turn your speaker off. Check. There you go. Now, can the folks at home hear me? Testing 2, 3. Okay. So American foulbrood infected larvae, look at here. This is not bright white. By the way, do I need to back up since the folks didn't hear? Okay, is
Yes, please. We didn't hear anything you said.
that a yes?
Yes, it is. I didn't hear a thing you said.
No.
for 2 minutes.
Let's back. I'm going the wrong way.
So we gotta go back.
Let's back up to the end.
That's the spot.
This is a rod-shaped bacteria that's growing actively in the vegetative state. But once it matures, it reproduces by forming spores, which you can think of kind of like seeds of a plant. And those spores can remain dormant for a very long period of time until they find themselves back into a bee's gut. When they find themselves back in a bee's gut, then you got active disease again. The problem is these spores can live 70, 75 years, or at least when I say live, that's a metaphor. They can cause disease after 70 years. This is what a healthy frame does not look like. I mean, this is a disease frame. It's black, it's tarry, it's got sunken cappings. You see this is perforated. This is sunken in. This is not normal. As we said earlier, healthy brood is medium brown and the top is rounded over or convex. Here's a developing larvae that died in development. Now, American foulbrood disease larvae die after the cell is sealed over. What they do, they die in the pre-pupal stage. They stop eating larval food and they spin a cocoon, and then that's the stage where they stop growing, die, and then they deteriorate and turn coffee colored and brown. And the reason it's called foulbrood is because when this dead brood putrefies, it has a foul odor. And that's one way you can identify it. It's not reliable, I must say, because not everybody's sniffer works the same. Some people can smell really good and identify this as something abnormal. Other people don't even notice it. And trust me, I've seen plenty of beekeepers, perfectly good beekeepers, that can't smell American foulbrood. So here's the healthy, here's the disease. It's an obvious difference. So at the very basic level, if you see coffee-colored brown larvae or pupae in your honeybee colony, call the apiary inspector for your region and get them to come out and identify it. That's our job, you know. And American foulbrood is easy to identify by field conditions if you are experienced. If you put a probe, in other words, American diseased foulbrood will be sealed over with those sunken cappings or perforated cappings. If you put a probe inside the diseased larvae, you stir it up and you withdraw the probe slowly, you're going to have the contents rope out because they're relatively viscous. And one reason this is helpful is because there are other diseases that cause larvae to turn brown, but it don't become viscous and it doesn't rope out like that. So that's an easy field way to differentiate. Once this disease process just goes on unnoticed, some of these dead larvae will eventually dry up. And when they dry up, we call it scale. And this is a whole panel of diseased cells that have had the contents dry up into what we call scale. And this scale cannot be removed by the bees. They can't be removed by the beekeeper. It's stuck in the bottom. It's a lot like asphalt. It's sticky and kind of cemented in there. And I put this on here because this is not a common sight, but this is a larval tongue. If the developing prepupa had kept going, that would have been its proboscis or its mouth parts. But at this stage, the only thing left is its proboscis. Usually this breaks off because it's very fragile. So this cell is also diseased. All these other cells are diseased and they don't have that. But if you see that, that's a dead ringer. That's American foulbrood. Nothing else causes that symptom. One infected cell can create 1 billion spores with a B. It only takes about a dozen or 15 spores to make one larvae sick. So you can see why it's an effective disease. Now, you may be wondering why all the colonies in North Carolina aren't sick with foulbrood. They do have some natural defense. One of the natural defenses is that it's developing larvae. If it gets exposed to foulbrood spores after 2 days old, it has no effect on it. It grows faster than the bacterium. It goes up to be an adult with no ill effects. So it has to come in those first 2 days, and it gets there by the nurse bees feeding it. And so the question comes, where do the nurse bees get these spores from? Contaminated honey. It gets in the colony's honey, and you see if this disease process goes unidentified and it's left to its natural course, the colony will get weaker and weaker because less and less brood is being hatched. They have honey on from when they weren't sick. And of course, what happens in the fall of the year, it usually starts in the spring and progresses through the season. In the fall of the year, honey supplies get short, bees get robby. They come looking for honey they can steal. They hit these weak colonies first. If the weak colony is weak because of American foulbrood, they rob all this honey away from the weak colony, and all of that honey is full of American foulbrood spores, and so they bring it back to their colony and give it to their larvae, and then it spreads like crazy. That's one reason why there's such a thing as an apiary inspector. Back in the 1920s, American foulbrood got so rampant in the US bee population that it threatened beekeeping as an industry. And they had to untangle what was going on here, why is it so contagious? And that's why they came up with the idea of an apiary inspector. Most states don't have one anymore. Well, I take that back. Because of tax revenues not being sufficient to keep them on staff. It can also get on surfaces of supers and wooden goods, and so you can clean all the wax off and put the stuff in the barn and forget about it and come back and put a package of bees in there 10, 15 years later, and you run the risk of that package breaking down with American foulbrood because the surfaces are covered with the spores. The bees naturally clean up the inside of the hive. They're going to ingest some of these spores. They're going to feed it to the young larvae, and boom, we're off to the races all over again. So how are you going to treat this stuff? Let's talk about prevention first. If you requeen with honeybee stock that have hygienic behavior, sometimes this can arrest the process before they ever get started. In other words, if that one first cell gets sick and you have an aggressive hygienic colony, they're going to take those contents out of the cell and dump it in the ground. But you see, the average type or the wild type bee has some hygienic behavior, but not that much. And they don't like messing with this coffee-colored sticky stuff, and they just leave it in place. And a few bees come along, which makes it almost worse than if they didn't touch it at all, and they try to clean it out, and then it gets distributed through the whole colony. Early detection is important because if you detect the process early on, you can limit the problem to the one colony that's affected before it gets robbed out and spread to all the other colonies in the neighborhood, especially your apiary is the first one to be infected. So that's why keeping your eyes open and being an observant beekeeper can catch this early on, and then you only have to deal with one colony. I tell the story when I first got started, I ran into, in this job, I ran into a beekeeper who had just made a bunch of splits. He was a large beekeeper, and I found 100 nukes that had American problem to deal with. If he'd have caught that problem before he made all those splits, it would have been a small problem. Antibiotics used to be a solution. If you're reading in some old literature, they can say, well, feed your bees oxytetracycline and it'll clear it up. Well, it will clear it up, but not for very long because it has no effect on the spores. It only kills the vegetative state. And so as soon as you quit feeding antibiotics, those latent spores that can last for 70 years come back into the food supply. And to keep your bees healthy all the time. It's just not only is it not recommended, it's just, now you can't buy antibiotics for honeybees unless you have a veterinary prescription or veterinary feed directive, as that points out. But American foulbrood is not a disease you want to treat with antibiotics. I'm going to show you how to treat it. You can destroy the honeybee colony and the bees and burn it up. There you go. That is, from the 1900s on to present, is still a surefire way to eliminate the disease. Fortunately, in North Carolina, we have another option, and that is we can put it in a fumigation chamber and fumigate it, sterilize it. This is a big old chamber that used to fumigate moon rocks from the Apollo mission. And when it quit bringing rocks back from the moon, it got in a surplus chain and we wound up with it. These spores are hard to just go out and spritz a little alcohol or a little chlorine bleach on them and kill them. They're pretty resistant. So to give you an idea how hard they are to kill, we can put dry comb in this chamber. In other words, we don't like to put scale in there if we can help it. We like to cut that out and burn it, the wax and the scale. But we can put contaminated wood goods and honey supers that don't have dead larvae in it in the chamber, and we can kill the American foulbrood spores so that you can go back and put it on your bees without having to worry about making them sick. We have to pull a vacuum. We pull a vacuum, then we inject the ethylene oxide gas under pressure, 24 pounds of pressure. We heat it up if it's cold weather to 90 degrees or warmer, so it increases the bioactivity of it. And let it sit for 2 days, 48 hours. And then we evacuate the chamber, and that'll do the job. But that's the same gas that some hospitals use to sterilize surgical equipment. And that works. If you got old rotten equipment, you might as well pile it up and set a match to it. And honeybees wax burns really well. It's not a problem. But
What's the cost of the chamber now?
it varies the size of the super, but you're talking about roughly $5 a super for a high body. That's to reimburse the state for the gas. We come pick it up, we take it up there and fumigate it, and then we bring it back to you for about $5 a super. All right. I would ask, well, I'm going to just ask, is there any questions about American foulbrood before we get to the next? The online crowd can type it in or shout it out.
Any questions about American foulbrood?
Yes.
You said that you mentioned about making your colony stronger, and they generally get weak, well, not weaker, but they have less honey going into the fall because maybe you pulled it off.
What I meant was the floral sources dry up in the fall, and so bees aren't working in the field, and they're looking for opportunities. And if you got a weak colony, they'll jump on it and steal their honey.
Okay, how do you make your colony stronger during that period?
You prevent it. You intervene when you have a colony that's becoming weak. That's how you keep them from getting weak. Or if they are weak and you're trying to build them back up, you reduce the entrance so they're not susceptible to being robbed out. And obviously you make sure they're not disease ridden. So you just take steps. But if you leave it with a full season entrance for a full size colony in the springtime, and they shrink down to a 3-frame nuke, and you're trying to nurse them back to health, you need to restrict the entrance. And then later on, we're going to talk about small hive beetles. You need to restrict the amount of comb space they have to patrol, because if they get too much comb space, things like beetles can take over. And we'll talk about that in a minute. Let's jump over here to European foulbrood. The reason I got European up Any more questions? Okay. European foul brood has got a similar name because it smells foul also. It's a different smell, kind of a subtle difference. It's not a reliable diagnostic to sniff it, but it can add to making a case for which it is. Many times European foul brood will affect larvae before it's sealed. Sometimes it can be similar to America when it is sealed and then it becomes sunken and perforated. This is mostly a stress disease. It's caused by gut stress, environmental stress of other types. It can be viral stress caused by varroa mites. The larvae tend to appear twisted and curled, and all of this is disease larvae. It's probably not a stellar picture. This is a cartoon picture that shows what it looks like in the early stages. The developing larvae become discolored, and these veins start showing up in contrast to their discoloration, and then it progresses to a darker color. And the modern version of this is that sometimes these are corn yellow, bright yellow, and other colors, because European foul brood presentation has changed in the last 15 years. Not sure why. Not sure anybody knows why. It's probably because it is mutated, or it's always been more than one. The Melissococcus pluton is the primary causative agent, but there's other opportunistic bacteria that join in the party, and probably some of them are making some of these strange colors. Terramycin or oxytetracycline is an effective treatment for this disease, and it does not. European foul brood is not a spore former. So once you kill it with antibiotics, it's down for the count, at least generally speaking. Many times you don't have to treat with anything, but it does require a veterinary feed directive or prescription. It's not nearly as dangerous as American. In the springtime, let me just back up. In the springtime, it can arise on the scene, not become an overwhelming problem, and then disappear as the colony grows and it's harvesting nectar and making honey, because that stimulates hygienic behavior. Here again, very hygienic bees rarely succumb to European foul brood in any kind of extension. It's usually limited by their behavior. Chalk brood. It's caused by a fungus, Ostophera apis, and the symptoms are this. This is, we've been looking at gooey brown stuff. This is bright white dry stuff. This is chalk. The name implies the texture. That's what it looks like when the bees drag it out of the cell. It's easy to remove. You can take a frame that's infected by chalk brood and tip it up, and these chalk brood mummies will fall out. The mummies are the remains of the pupa after the fruiting bodies have taken over. They're easily removed. These are the fruiting bodies on the outside. The solution is to requeen a colony that has a bad case of chalk brood, because there again, a hygienic colony will not allow that to get a foothold. And as far as treatment, there is no treatment. You can stimulate it, hygienic behavior, by feeding it if there's no honey coming in, and you cannot make splits with it. Flip over to sac brood. Sac brood is a viral disease, and it's in here partially to differentiate it between some of these other diseases. It's caused by a virus. The larvae are dead. They die with their tails straight up. American foul brood, the larvae die in the prepupal stage, which is, if you catch them before they completely melt down, their tails and their heads are both up. It's kind of a boat-shaped larvae, even after it begins to die. But it eventually will melt down flat. Sac brood is a boat-shaped disease larvae. This is a sick larva. It's dead. You notice it's not as discolored as the other disease, but it does have that heads up, tails up appearance. if you put a probe in there and you get an intact one, you can remove the whole thing with the contents in a sac, which would be would have been the bee's beginning exoskeleton. And so that's why the term sac brood, the common name sac brood. It's full of viral particles. It's usually worse in the spring. There is no treatment for it. It's a virus. We don't have any viral treatments, but it's worse in the spring and it's stress related. Sometimes it'll show up along with European foul brood, which is another stress related disease. Any questions about those European and sac brood before we move on? All right.
Any questions, y'all?
Okay, let's move on then. I've got trachomites on here. Trachomites devastated the beekeeping population, the bee population in North Carolina back in the 80s. But I'm happy to say it's not a serious problem today. I hope it never comes back again. If you look hard enough, you can probably find a trachomite or two, but they're difficult to even find. There's a lot of theories for that. Nobody knows for sure, but it's hard to find one. You'll see when you're reading in the literature about how devastating they can be. That's true, but not now, at least not now in North Carolina. This is what the little guy looks like. He's microscopic. That's 400x magnification. He's a mite, which means he's got 8 legs. You can think tick, mite, tick, same thing. Well, almost the same thing. They infect the bee's trachea, hence the name trachomites. And the breathing tubes, the large ones right behind the neck, the ones that get most of the oxygen into the bee's body so that they can feed these big flight muscles that allow them to fly. You clear that soft tissue away and you can see the mites through the trachea. This is internal. What they do, they get inside the trachea, they pierce the skin, they eat the hemolymph, the bee's blood. They got a small beak-like mouth. This is the mouth right there. This is a terrible case. About half of the honeybees in North Carolina died when this came along, out of the blue, so to speak. And this is about as bad a case as you'll ever see. See, this trachea should be relatively clear. It's darkened by feces and mite debris from being so infected. And bees like this can't fly. Their flight muscles get weak. This is a group of bees shaken into a lid and they can't fly. They just crawl. They're useless. The only way to diagnose it is to take a sample of bees. You cut the head off and you cut slices through their thorax. You clear the soft tissue and then you can visualize these trachomites. And you can also quantify them. And once upon a time, we had a technician hired that didn't do anything but cut bees up all day, every day, and look for trachomites. Fortunately, we don't do that anymore. I got a little quick video because you don't see many videos like this. And this is a tracheomite teased out in our lab at Raleigh. Teased out of the trachea, and he's like, wait, where's my host? I'm looking for a bee to infect. And you just don't see that every day, so I wanted to share it with you. Fortunately, I can tell you that the trachomites are not currently a problem. You little rascal, get lost. Terrible. I lived through the trachomite era. It wasn't fun. The treatment in the day was menthol. It still is, although there's no reason to treat because I can't hardly find the things. One theory is some of the treatments that we use for varroa mite, which we're going to talk about in a minute, may be killing trachomites. But before varroa came along, I think it's pretty obvious that the bees that were left surviving from this onslaught are somewhat resistant. So I'm pretty sure, pretty confident that our bees are resistant. To what degree, I hope we don't have to find out. And here's the big elephant in the room, varroa mites. If you don't remember anything else about my talk today, remember that there's 2 major disease pests currently of honeybees. and that is varroa mites and American foulbrood. They're devastating if you don't handle them. One you handle by early detection, and the other you handle by what we're going to talk about right now. Varroa destructor. That's a good name because destruction is the name of the game. This large external parasite parasitizes the adult bees. Reproduction takes place inside the cell with the brood, and the mites feed on the developing larvae. So this mite parasitizes the adult bee and the developing larvae, and all of its mite's reproduction takes place in the cell with the larvae. Mites enter the brood cell just prior to capping. The female mite lays eggs, immatures develop and breed until the bee emerges. Now you might ask, where do they come from? That's a good question. Investigation suggests that we got them in the United States because some smart hobby beekeeper put some in a suitcase and flew in, because it's illegal, by the way, to import bees in the US from another continent or from Canada for that matter. Currently, it's just illegal for disease purposes. Somebody put some queens in a suitcase, flew in, landed in Florida, put them in his hives, and next thing you know, this mite was all over the United States. But before that, where did it get up? It's not even originally a pest of European honeybees. It was originally a pest of Asian honeybees, Apis ceranae. And what happened was in Apis ceranae, this parasite only affects drones in relatively modest numbers. So that the honeybee, the wild honeybees, unmanaged honeybees, Apis ceranae, can live and breed and thrive with this mite. Mite is not devastating. But then people started putting European bees in the same geographical area as Apis ceranae, and this mite said, wow, these guys are close. Let's jump over here. And they successfully transferred to European honeybees. And in European honeybees, they could parasitize the drones and the workers. And this caused colony loss because you've got a mismatch. This parasite doesn't belong on this host. And that's where we are today. This is a video that's going to probably maybe tell you a little bit better or more entertaining than if you listen to me talk about the life cycle of the varroa mite.
Varroa mite. Well, to be precise, we'd like to introduce you to millions. We'd like to introduce you to the varroa mite. Well, to be precise, we'd like to introduce you to millions of varroa mites. Why so many? Well, when it comes to the varroa mite, there's no such thing as just one. And if you'd like to see how an infestation starts, further than your own bees, especially drones, as they're pretty social and like to travel between hives. Since varroa mites don't have any wings of their own, they slip into hives by hitching a ride on the backs of adult bees. And for the lucky mite, the trip includes an in-flight meal, as varroa mites will begin feeding on bee blood within a few minutes of clinging to the bee. Once they've entered the hive, varroa mites slip undetected into the vulnerable, uncapped brood cells. This is where the mites lay in wait until the bees cap the brood. Once a cell is capped, the mother mite, like a tiny vampire, climbs atop the cocoon of the developing bee, tears open a hole, and begins to feed on its blood. Within 3 days, the mother mite lays her first egg, which always develops into a male. Then she lays one female egg every 30 hours over the next week or so in her newly acquired home under the brood cap. As each of these female mites mature, they mate with their brother. By the time the baby bee develops and leaves its infested cell, as many as 3 fertilized mites will emerge with it, and it continues. Using this strategy, the varroa mite population can grow as fast as the bee population it feeds on. But when summer ends and the bee population declines, the hive is left with a huge mite population, and that's dangerous. Too many mites in a hive will overwhelm and kill entire bee colonies. So what does that mean for everyone's favorite insect, the honeybee? Well, honeybee colonies with heavy mite infestations can't effectively pollinate or produce honey because they suffer from diseases and viruses transmitted by the mites. In fact, honeybees suffer from as many as 20 different mite-induced viruses, including the devastating deformed wing virus, which prevents them from flying.
I think that's enough.
I'd like to introduce you to.
Okay, that's enough. That's most of it. That's just the background of how mites reproduce. At any given time when you go into your bee colony, on average, 85% of the mites are in the brood. So they shouldn't be easily discernible just by looking, because if you can see them easily, your numbers are way too high. This is what it looks like when the mites are feeding on the adults. That's called the phoretic stage. And they're not inside of a brood cell. They're waiting for opportunity to get into another cell to reproduce. And they can feed. See these plates. These plates on the bees overlap like armor. And the mite can slip between the two plates because this, bee's got a hard exoskeleton, but she's got to breathe. And so that's how the insect breathes. The mite slips in between these plates, pierces her skin. The little movie says blood, but actually it's fat, mostly fat and a little blood. We've come to realize that. And so this weakens the adult bee, but most of the damage is done through the developing pupa. See, here you got this deformed wing syndrome. Deformed wing is not actually caused by the actual piercing of the skin. It's caused by a virus that the mite vectors, or the virus lives inside the mite. The mite spreads the virus every time it feeds. The virus causes deformities in the bee, undersized, their wings are formed. There's two different types of deformed wing virus. One type, A and B, one type doesn't necessarily have deformed wings. It just devastates the bee. It affects all of their internal organs and it weakens their immune system. Not nice. That shows the different ages of brood on an emerging drone. You got everything from the males are the small white guy. He never survives past the reproductive brood stage. And once the bee emerges from the cell, if it's not destroyed, the male dies. And then all of the female mites that have been produced will survive if they're old enough. So basically, the first egg that the female mite lays is a male egg, and then subsequent eggs are female about every 30 hours. And the brother and mates with his sisters. That's just the way they roll. And so they're close breeders. And that's how you effect reproduction. And she lays eggs every 30 hours, but the last one's laid, the bee is going to emerge before they're old enough. If they're still white, they'll desiccate when they emerge. But the ones that are medium brown, like this guy or gal, she'll be all right because she's beginning to harden her exoskeleton and she won't dehydrate. That's another look at them. Here again, it's a classic mite / think ticks. And let me just tell you something about the relative size of a varroa mite on a honeybee. It's a large parasite. You don't need a microscope, obviously. To use a comparison, if it was a tick on us, it would be the size of my outstretched hand. So you can imagine a tick feeding on your body. And some people say varroa mites, no big deal. The bee's just gonna have to learn to live with it. Well, they don't do a good job of living with it. They do a good job of dying with it. But if you went for a walk in the woods and you came back and you had ticks on you from your walk in the woods in the summertime, and they were this big, and you had 2 or 3 of them, and you told your spouse you need some help getting these things off. And they said, oh, don't worry about that. That's no problem. Well, would you, I'd have a problem. I think you'd have a problem if you had a tick this size sucking your blood. It's like a snapping turtle riding around. You don't want that. So it can cause deformities. It can cause weak workers. It can cause a low population. We already talked about that. You can't see them at a low level. That just reiterates the first, every 30 hours, the first one a little bit longer, about every 60 hours for the first one and then 30 hours thereafter. But the damage doesn't necessarily come from, mostly from the piercing the skin, the taking the nutrients away. The real damage comes from the diseases they vector. If you get a tick bite, it's a sore red spot, right? No big deal. But have you heard of Lyme disease? Now you got a problem. If you get a full-blown case of Lyme disease, it can be a devastating disease. Ehrlichiosis, Rocky Mountain spotted tick fever, the red meat disease is a gamma globulin problem with another tick disease, tick-borne disease. It can make you allergic to red meat, so you have to give up burgers for. Some people recover after 8 or 10 years, but if you're a red meat lover, that would be a problem. So this is the kind of thing you can think about in your honeybee colony. You got these mites / ticks piercing the developing bees, spreading disease, and that causes problems with the mortality, the individual mortality as well as the colony mortality. This is a extreme case. These workers are useless. This is a video of a drone emerging, and I want you to count the number of mites you see on this emerging drone, if we can make my video work. Just count. Some of them are already out, like this one over here. Don't forget these down here. Oh, did I hit that thing? I hope I didn't do that. Come on. So if anybody tells you that mites aren't a problem, just get this image in your head of this young drone trying to be born into the world, and he's got 6, 7, 8 mites crawling all over his head, and he hadn't even got out of his cell yet. They prefer drones because drones take longer to develop and it gives them more time to reproduce. But varroa mites are a serious problem for honeybees. A lot of effort has gone into developing resistant honeybees. Many different angles of attack, grooming behavior, hygienic behavior, being able to detect being able to detect mites in the developing pupa, and they, in one case, the bees can actually discern between high fertility mites and low fertility mites, and they'll destroy the developing pupa from the cell that has high fertility mites and leave the low fertility mites alone, and thereby cultivate a low reproduction mite, which allows them to tolerate the infestation. Pretty cool. I don't think anybody knows exactly how that works, but currently I'm not aware of any genetic breeding program that produces a bee that can tolerate varroa mites without some other manipulation or management or treatment. Sometimes you can combine a resistant bee with another manipulation that doesn't involve treating, a chemical treatment, if you will. Here's a partial list of the viruses that you can find inside a honeybee colony that are all vectored by varroa mites. And all these viruses have different symptoms. The paralysis virus, of course, or have paralysis as a symptom. But one thing they have in common is they shorten adult bees' lifespan. And that has devastating effects when you're talking about winter mortality. because when winter comes, the workers, instead of living 6 or 8 weeks, they have to live 3 to 4 months to get to springtime where they can start reproducing again. And if you have dramatically shortened lifespans, they can't make it to spring. The colony shrinks in the wintertime and becomes unviable and it dies. And that's what leads to a lot of mortality. And these processes are set in motion in July and August in this part of the country. And you have to intervene in July and August in order to protect your bees for the winter. And I'm going to tell you more about that in a minute. This spotty pattern here is not caused by any kind of foul brood. It's caused by varroa mites and their virus complex. Some of these viruses kill the developing larvae. It's not European foul brood. It's not American foul brood. It's not sac brood, although sometimes it is. And varroa mites can spread sac brood, I must say. But here's some corn yellow. A lot of times you see this at the same time as some European heats, you can have a mixed infection. And a lot of times this is varroa virus complex, or many slang names for it, but it ain't good. They've uncapped these pupa. These are already developing. These are not larvae, they're pupa. They've chewed the heads off. They've exposed a couple of mites inside. They're dragging these developing pupa out of the cell to try to retard the reproduction of the varroa mite. This is kind of a good thing because this is hygienic behavior, but it also drags the colony back. You see these deformed and discolored larvae? That's viral infection. And it's caused by high levels of varroa mite. It shortens adult lifespans from 34 to 68%. We see if you have a bee that in the summertime, a healthy bee lives 6 or 7 weeks, and you shorten it by a couple of weeks, you probably won't even notice. The colony production won't be what it would have been, but you won't notice because there's a rapid turnover. But in the wintertime, where the queen almost quits laying, and you have this winter bees that are supposed to live 3 or 4 months, and you shorten their lifespan by half, they're going to live a month or less, and that doesn't bode well for colony survival. Here's a chart showing what happens when you have, starting in the spring, you have rapid colony increase on this line. This is the bee population. And then the mite population depends on what? The brood to reproduce. So in the early spring, there's not a lot of brood, so it retards the mite's reproduction. But as the brood in the colony increases, so does the varroa mite reproduction. Well, then in late summer, when there's not honey coming in, and fall is right around the corner, we have a reduction in the bee population, but the mite population continues with basically a geometric or logarithmic increase. And so the amount of mites per bee goes up dramatically at this part of the graph. And so right when you're going into winter, where it's very important, you have these extra high varroa mite levels spreading viral disease, shortening their lifespan, and it's a perfect storm. It can lead to disaster. It can lead to these 50% colony mortalities that you read about. Might be going the wrong way. It's just making a point. As varroa came along, we already had viruses in bee colonies, but they didn't spread easily. When varroa came along, they have a new route to spread very easily and in large numbers. So in the old days, you get 300 or 400 sick bees with a virus. Now you get the whole colony can get infected with the virus. The queen can spread viral particles. The nurse bees can feed viral particles to developing larvae. And so the higher the level of varroa mites, the higher the overall colony virus levels are. You can call it a virus titer, if you will. Then once you get rid of the large numbers of varroa mites, there's a lag between the time the virus levels in the colony go down and the varroa mites. You control varroa here. There's about a 40 to 45 day lag before the viral levels come down, because that's how long it takes for the old bees to die and be replaced by new bees raised in a low virus environment. That's why you got to control things in July and August before winter gets here, because if you wait till just before winter,
Question. With the drone population,
some people use drone brood to capture varroa mites, and they take them out before the drone brood hatches and freeze them to destroy the mites and the brood and return them to the colony. That is a control strategy. But if you just put drone brood in the colony, it actually helps the varroa to reproduce. And so you'll get higher numbers than you would have if there wasn't drones.
Back up on two, sort of like that.
Yeah, go ahead.
Interruption of the breeding cycle.
Yes, right. You can do something simple as a walk-away split or requeen with a cell even, and that causes a break in the brood cycle. That reduces the opportunity for the varroa to reproduce in the cell. It provides a break in their reproduction, and the older these fertile mites or these phoretic mites get riding around on the back of bees, the more likely they are to get damaged or to get old. And when they get old, they don't reproduce. When they get one of their 8 legs broken, they die. So if anything happens to them, so by giving a brood break, you see, you can find a brood break with something else like a highly resistant bee, and you can possibly control your varroa problem not semi-naturally that way.
That's what I was asking them, what you said, control using chemical treatment. Chemical treatment.
Well, you got a lot of choices. We're going to talk about treatments here in just a second. We already talked about there's 2 types, deformed A and B is the worst. It does a lot of things. It changes foraging behavior, deformed wing bee. Shortened lifespans is not the only symptom. One rather common symptom is that lose their ability to regulate their temperature. And so when the weather gets cold, if you have virus infected bees, they fly outside the colony, they lose their ability to create enough heat to get back home, and they just disappear, so to speak. Some people think their colonies collapsed or they swarmed or they absconded. But what it was is their sick bees go outside, they get chilled, and they never come home. So you don't see dead bees at the colony, they just disappear. We don't need to cover that. Bee paralysis is caused by we already covered that. Here's the part about managing your problem. You can't manage something that if you can't quantify it, you don't know what your problem is. And one way you can quantify it is to do varroa checks, varroa population level checks. And what we want is a number of adult phoretic mites per 100 bees. And researchers have come up with a plan to do this. You collect 300 bee sample is big enough to be representative. And one way you can do it is, 2 ways is sugar shake and alcohol wash. You can put powdered sugar in a container with 300 bees, and you put a screen lid with sugar. It causes the mites to dislodge. The mites got sticky pads, powdered sugar makes them release. And then you can shake them through the screen, leave the bees behind, shake the varroa mites and the powdered sugar out, and then count the varroa mites and 300 bees, and you come up with a percentage. And you get if there are 2, my recommendation in North Carolina is we want to keep it below 2%. So if you had 300 mites and you had 300 bees and you had 6 mites, you'd be at the 2% threshold. And in the springtime, we'd like to see coming out of out of the winter, we'd like to see it 1% or less, because you don't want to start at 2% because you'll be way over 3% before fall, way over, might be 6%. So start with 1% and try to keep it below 2%. Some books will allow you 3%, but in the fall, but I prefer you watch it at 2%, make that your action level. And then if you got honey on the bees, you may have to wait and it buys you some time. Don't wait till you have 3% problem. And you can shake that sugar on a white background, or you can put it in some water on a white background and count the mites. And there's the math for you. You know, 1% in the spring is 1 mite per 100 bees, which would be 3 mites in a 300 bee sample. And if you want to know how many 300 bees is, a half a cup, it's a kitchen measure, volumetric half a cup, shaken off roughly level is 300 bees. Very, very, pretty amazingly accurate. Let's put it like that. July and August in North Carolina is the target time to treat. As soon as you get your honey off and you get a break, start testing. You can't test too much. I suggest try to do it every other month. Do it coming out of the winter. Do it before you treat. If you're trying to limit the exposure to whatever the treatment is, then you got to do it before you decide to treat and know what the levels are. If the level's low enough, you might wait till another opportunity later. If you do it every other month, at the very least, you'll have a feel for how the mite population in your location changes over the season, because that's important information, because your neighbor down the road or somebody in North Dakota, their mite population is not going to grow the same as yours. And so what's important is what yours is doing. Here's some options. When I was talking about control, you got options that aren't the same. You got soft options and harder options. When I say soft, I mean chemicals that are found in nature that have been packaged for use to control mites. Formic acid is one. It's got its own problems, mainly being temperature sensitive. Pigard is based on thymol. That's a natural plant product, and it can control mites. It's a fumigant, and it's got temperature restrictions as well, but not as bad as Formic Pro. Oxalic acid is inexpensive. Its cold weather use is the most effective, but many people use it now in warm weather. In warm weather, you just about have to use a sublimation method, which basically involves heating the crystals and fumigating the colony. And since it doesn't bother the mites that are in the cappings, you have to do it spaced out over a period of several weeks in order to have an effect. Brood interruption we talked about, I mean, at a very basic level, you can actually cage a queen for a couple of weeks and then release it. That's a brood interruption. But testing is the most valuable thing you can do. You can't make good decisions if you don't have good data, good information. Here's the alternatives. You can do drone brood entrapment, where that actually works well. Most people can't do it because they forget it. They leave the drone brood in too long. They hatch a bunch of mites, and they actually make it worse instead of better. But there's one person in North Carolina that does a good job, but he's unusual. Brood interruption strategy, that works. Best to combine it with another strategy. Like if you're doing oxalic acid, you can interrupt your brood and then wait till the end of that brood interruption strategy cycle time period, and then shoot them with oxalic. And you got more mites outside of the brood at that time and get exposed to the oxalic. So it makes it more effective. You know, you got hygienic stock, you got broil sensitive hygiene stock. That's the stock that can sense how reproductive the mites are, and they drag out the pupa with the most reproductive mites and leave the less reproductives inside. Hygienic stock, you know what that is, I think. They got the ankle biters. That's a grooming type of behavior where the actual bees will see a mite on another bee and run over there and bite its leg. If it bites one leg, mite's gonna die, which is cool. And the Proline, that's a USDA developed line, which is actually so was VSH. And as a couple of people experimenting with that in North Carolina, and the early results are promising. So it's just another broil resistant stock. So it'd be worth thinking about. It'd be worth paying a little extra money for a queen that has improved genetics that are tolerant or resistant to broil. So with all these treatments, follow the label directions. The label is the law. You got Apigard, you got Apis. No, don't use Apistan but they're ineffective in North Carolina. They're like less than 50%. So don't use the white strips and don't use the yellow strip. Pest threat's dynamic, and you got to keep up with the latest literature so you know how it's changing. There's a lot of literature out there that was written in 1992, and it's horrible information now because the mites gotten worse and our information's gotten better. So pay attention to how current the literature that you're reading is. And as always, when you go to Mr. YouTube or Mr. Google, be cautious. You got to good information, what's mediocre and what's awful. And if you're a beginner, sometimes that's hard to do. So get somebody to help you with that. Just mentioned Nosema. It's a gut disease. It used to be caused by, in other words, Nosema has completely changed. It used to be a gut disease that was only in the wintertime. Now, Nosema ceranae, Nosema apis is the old one. It's almost been replaced by Nosema ceranae. It's a more serious Nosema. It's still a Nosema. It's microsporidium. They can't decide what it is. It's been a couple of different labels, but it's still the same pest. We'll call it a microsporidium for now until the taxonomists change it again. It can cause a discolored gut. This would be a normal gut. That's an inflamed gut. Used to be able to buy Fumidil B and treat it. Fumidil B is not available anymore. If it was available, you need a veterinary prescription. There might be a similar product available from Canada, but it's controversial about whether it's even worthwhile to treat or not. So if you think you got a Nosema problem, give me a call. We'll sort it out. These guys, they look kind of like a pollen beetle, but they're not. That's the larval stage. They got these prolegs. And they can look a little bit similar to a wax moth larvae, but they're not. That gives you some idea of the nymph stage. That's the developing stage. This pest showed up in Florida. Before it showed up in Florida, the last known place that it was prevalent was the continent of Africa. How it got from Africa to Florida, nobody knows. The adult bee can lay many eggs. Beetle lays eggs. If the eggs go undisturbed and they hatch, and the larvae eats just about anything. They eat pollen, they eat honey, they eat brood, they eat everything. And they have a terrible habit of making slime. Basically, they eat detritus in the colony, anything they can find, and they exude or defecate a slimy substance that encourages honey to ferment. It's full of yeast. And it makes what you saw in that picture. Basically, this is greasy, and this is small larvae that look for all the world like fly maggots. And you don't want that in your bees. It's terrible. Bee larvae, honey, pollen, eats it all. So how do you, and that's up close in case you want to see some gross pictures. You don't want it to get that far. The only thing you can do is prevent it. Once it gets that far, it's too late. The adult beetle enters the colony and finds food and shelter. The females lay eggs. One female can lay thousands of eggs in a month, and the population of the beetles can explode. When these larvae hatch, at that time, they're pretty much impervious to the honeybee workers' harassment. I mean, they're just going about their business. And if you got a bad case of them, the slime area gets bigger and bigger. The bees retreat from the slime, and pretty soon they all huddled in one corner, and eventually they'll abscond. But a strong colony that's otherwise healthy, when these beetles come in to lay eggs, the house bees will come along and chomp down on these eggs, and they don't belong there, and dump them out and destroy them. And so they never get started. You don't see any larvae. I've seen colonies in the fall that had 15,000 beetles and no larvae, no damage, if you will, because the beetles don't parasitize the adults. The adult beetles don't parasitize the larvae. The only thing they're going to do is eat pollen and detritus on the bottom board. But the problem comes in if the worker population gets reduced and these beetles start laying eggs that don't get consumed or destroyed, then you get larvae, and the larvae start making slime, and then you're off to the races, and it starts a downhill slide. They can go downhill really fast. Part of their development period, when these larvae reach a proper age to pupate, they swarm outside the colony, go into the ground, and that's where they finish development in the soil, in the nymph to the adult stage, and then adult beetles come out of the soil. They're tough too. They don't die easily. In cold weather, they just simply arrest the development, stay in the soil until it gets warm. Early on in this process, there was a researcher who put a yard of bees on a abandoned airport runway, concrete runway, to see how to take care of them, right? And the rascals, they always swarm at night anyway, probably to avoid predation. When swarm, meaning the larvae swarm outside the colony, the small hive larvae. They come out in a rush all at one time. They don't just fizzle out. They just, it's kind of unusual if you ever see it. The airport bees, the beetle larvae, just simply crawl as far as they had to. If it was 100 yards, they crawled 100 yards. Didn't matter. Until they got to the edge of the runway, then they went in the soil. So they were undeterred by this huge concrete expanse. And you can dig them up out of the ground with a hive tool. That's where those pictures came from. One control is you can staple these white strips that don't work for Varroa anymore onto the back of a corrugated sheet and put them in the colony upside down where the bees don't come in contact with the strips, and the beetle sometimes run under there to hide, and they get exposed and die. West trap works for some people. In between the frame trap works for some people. Put some mineral oil in there. You can put dish detergent in there. You can bait the trap. You can put some beer in there, fermented product. I tell people don't clean them out when they get full of beetles completely. Leave some dead beetles in there, and that attracts more beetles. Live beetles come to smell the dead ones, and they get trapped. So they keep the process going. Here we're talking about matching small colonies to the comb surface. If your colony gets queen event, something happens, queen goes bad, they don't reproduce. You got a small colony, you got a formerly big colony, they can't patrol the comb surface, and these beetles can run wild that way. So you have to take steps to get the combs out of there and store it in a safe spot, or put it on a strong hive, and then keep the small colony with just enough space where the bees can patrol the surface. And then you'll help keep them from being overrun by small hive beetles. That gives you an up close view of what the beetle looks like. Strong colonies is really the solution here. Any questions about small hive beetles? I'll tell you what, I know my time's running out. I'm just going to talk about wax moths. This is an issue that I hear people all the time say my bee colony died because of wax moths. And let me just say up front that wax moths don't kill bees or colonies. Wax moths are opportunistic invaders. When a colony gets weak, they move in and start taking over. They eat the debris in the comb. They're actually not looking for the actual wax. They're looking for the larval skins and the pollen, the debris, and in the brood comb. That's why it's very attractive. And they want that. That's what they eat. And they can cause a lot of damage because these larvae, when they decide to spin a cocoon, they can tunnel out. They can chew your wooden goods up and make it weak. Basically, they can destroy a frame is what I'm getting at. If you have a hive body that gets eaten up by wax moths, they can pretty much destroy your frame. You got to go crazy. strong colonies are the secret. And the same thing with small hive beetles, match the comb space to the size of the colony. Get a little colony, give them a little bit of comb, and then add it slowly as they grow. Otherwise, you run the risk. You can use paradichlorobenzene. That's the only one that can control wax moths without killing bees. If you buy any wax moth control product, most of them will kill bees. Paradichlorobenzene, which is made for honeybee comb storage, can control small hive beetles and wax moths. And all you got to do is air the supers out before you put it on your bees. You don't give this to the colony with bees in it. You just put it in your storage area and it'll kill the wax moth. Skunks, they like to come up to the colony and scratch on the outside and make the bees come out, and then they chew the bees up and get the sweet contents of their stomach. It's like a snack to them. I don't know why it doesn't discourage them from the sting. Possums sometimes will do something similar. You see these tufts of dead bees in the front all chewed up. That's a sure sign you've had skunk. And sometimes a possum. If you see that in your yard, is either had a tornado or a black in a short amount of time. But fortunately, most of them are just passing through in this part of the world, and they don't know how to really make a mess until they practice. The solution for black bears is to build a good electric fence. It can be, I'm a minimalist, it can be as few as 2 wires that are hot, and I mean hot. Because modern electric fencing has gotten a lot better than it used to be just when I started keeping bees. And so in the old days, if you had 2,000 volts, you were doing good. Now you can have 10,000 volts. And that all leads to the sensation the bear gets. So basically you can control black bears with a hot electric fence. And if you need any help with that, I'm sure Barry can tell you, I can tell you how to build a fence. This is just a summary of what we've covered: American Firebird, European sack, chalk, royal mites, tracher mites, small hive beetle, Noxema, wax moths, and bears. It could be discouraging, but it shouldn't be, because it's just like everything else. It has its problems, but every one of these problems have a solution. And if you need any help with it, contact me or your mentor. Thanks.
Thank you, Adolphus.
You bet.
You know, there's a lot given out, but I can tell you, you will see and hear all of that again. Not only for testing purposes, you will see, hear, and smell all that again around your beehive. So hopefully you took good notes, and like I said, China and Ara are going to make that make this available in Google Docs. What I'm going to do is, before I get started about year-round beekeeping, everybody reach break or bathroom, whatever. I started that, not go all the way to 5, just minutes. All right. But I want to thank Adolphus again. Adolphus lives in the Falkland area. Now, I know we didn't talk about this, but I want to say, when he comes out, if you call him, you got to give him time. And the inspections, there's no charge. He will come, but you can't call him and say, Adolphus, my bees look like they're gonna stun, and I need you out in 30 minutes. That don't work. But if you call him, lay on the time, he definitely will come. Or if he know where your hives are, especially to have done mine, as he's driving by, he see my hive, he will check, and if he finds a situation, he calls. So, but that's all part of what we beekeepers have here in the state have been made to us. But that's why I was even asking him about. I knew there was a cost for fumigation, but that's real. I didn't know you guys pick them up now. They'll come and pick them up?
Small quantities.
Okay. So that's something new on me. I didn't know that. We always used to pick them up.
That's because you guys had truckloads.
Yeah. But the fumigation chamber is located, those of you who know Raleigh, is located right on that same hill with the Raleigh Farmers Market, but it's around, I think it's Brandon Street. But then when you go around, go past the farmers market and go around, those of you that may need some of that right now, I don't think I know of anybody in this class that need that right now. If you already got that big of a problem, I'm too late. But look, take a little quick break, let Adolphus go. And
All right, it's 4:32 now, so what time do you want them to come back to their computers?
say 4:32, say 4:40. 4:40, everybody back. All right, thank you. Appreciate that.
Thanks, sir.
Thank you, Adolphus.
Thank you. Good luck with the rest.
Thank you. Whatever you want. I guess he'll cut himself off when he'll go out. I muted him, but I guess he'll take himself off eventually, but he'll leave or whatever. But, I just put mine,
So go put yours back.
yeah, I did put mine back on. I'm gonna come in, when they come back in at 4:40, I will ask him if they can hear. Yeah, I will ask them if they can hear, and then we'll figure out between me and you which one we need to do. You got 7 minutes. Hi, Mr. Richard, how are you? I bet. Mhm.
Hey, everybody, back, real quick. Let me focus, get out of that. All right, what we're gonna do is, I'm gonna cut I'm only gonna, speak a little bit about the, year-round beekeeping, but I'm gonna make sure that Ara or Channel have it, and put it in the Google box where you can see, because that's whole 12 months, we don't have 12 months time to go in. But right now, we'll talk about where we are right now in it, and that is, June. The 2 months that are together is July and August. We started to speak about the July and August. This is a time that rural might everything increases. And you look at some of the older books or some of the new books they got printed out now, they talk about a dearth. There's a lack of pollen and nectar out there for the bees to collect. Well, that kind of shifted somewhat. You know, everybody talks about season change, well, all this stuff, but it has kind of shifted. We beekeepers recognize that. It shifted down into June. There's not as much floral or flowers with pollen and nectar. So right now, the bees, they will rob a lot quicker. I hope everybody understands. You can see that word or hear that word a lot. Rob. It's when bees, and they act just like robbers too. They will sneak in or break into another bee colony and they would take their honey. They would steal their honey. If right now, if bees are robbing the hive, if I walk in and pull the lid off, they'll act just like robbers. They'll scatter. So it's actually robbing. They will tear up the hive, they will tear up the comb, they will eat. They take the honey and take it over to their hive. So this is a very critical time for us in these months right here, because not only do that stress the bees out, that they can't find food, they let off a stress pheromone. That stress pheromone attracts hive beetles, attracts wax moths, all of that. Usually, guys like myself that's into pollination, we're moving bees about this time of year. That's stress. So you gotta watch that. You gotta keep a close eye on for your different diseases. But that's why I asked for dolphins now. Some of you haven't been around as long as I have, and it's not bragging on me. Most of the time when I walk into one of my bee yards where I got 10 or more hives, I can smell something. It's not me, no, it's not me. I can smell something. Like he was talking about the hive beetles. That's a fermentation. It almost smells like somebody making whiskey or something. So as I'm walking in the yard, I can smell it. Or as I open up one of the boxes, that smell come out. I mean, you by the time you open the box, you can see it down. Wax moths have a dusty, dirty smell to me. Like, you know, you're up on an old house and the plank, you pull the planks loose. Wax moths have that smell to me. Foul brood, just what it says. It's, you get your hands in, you're driving down the road, or like me, sometimes I drop down on my knee, it gets on your clothes, it's gonna follow. It really is foul. I mean, it's, let me see. I don't know that comparison to it, but I know it's a very stinky, rotten smell. And inside the beehive smell good. You know, it smells of pollen, it smells of honey, it smells of nectar. So as soon as you open up that hive, I've noticed like right around time when there's a lot of goldenrod. With goldenrod, the bees collecting that pollen, you open it up, I can smell that goldenrod. So if you got allergy to goldenrod, don't mess with your bees during that time, for a lot of pollens in. But I can smell it. Clary sage, the clary sage has the same kind of smell. But what I'm getting at is this time of month, I'm gonna say right now, because we're in the latter part of June. So July and August, reduce the stress on your bees. Don't go in them a lot. Do what I call drive-by. If you look at your hive is flying, doing what it's supposed to do. Bees down in front, and the bees doing what they need to do. Don't go in. That causes more stress. If you just got to do something with your bees, go in them this time of month, June and August, July and August. Go in and come out. Next thing I talked to you about real quick was robbing. Don't scrape things off. Like some of us beekeepers scrape off beer comb and stuff. Anything that got honey on it that you drop down on the ground, that can cause robbing, especially if that hive is not that strong. So don't. And like I said, anytime you're in the hive, don't drop down and leave things called robbing. Or most of the time we start trying to supplement the feed. So if you're going to supplement feeding them, if that stuff starts, if you overfill it and it runs in the bottom, or you overfill it or it run down the side, you try to do something like that, you waste, you're gonna cause robbery. Quick story, I had 28 hives on the bus. The only hive, and they was on that bus for 5 years. And the only time I lost a hive of bees to robber on that bus was me doing what I just said. I spilled feed, it ran down the side and got in there, the bees robbing out. That was the only hive I lost. So it's things like that. You gotta understand your bees. What we're gonna do is, at the next class, we are going to, we're gonna talk about each month, the 12 months of year-round beekeeping. Because right now, we should already got through with this stress area. We should be into Fahrenheit bees for 1 month. It's also part of those of you who are here, that's here in the class, for the mutual certification, becoming a certified beekeeper. But all of that falls right in. I don't want to stand up here and stomp my foot, say, listen at this, listen at that. Everything that was put out, especially about dog, you're gonna see that again. You may not see as much of it, but you're gonna see that again. American foul brood, European foul brood. Yeah. Sack brood, chalk brood. Hey, did you notice that? I got a compliment. There was a thing changed. I used to get fussed out about it. I mean, I just found it out from somebody else, but the chalk brood, there used to be a treatment for it, but I noticed he said there was no treatment for it. And I always said, requeen. Put a new queen in. And I used to say, no, you lazy thing, you need to do this, do that. But no, that's the thing that I saw up there. You requeen. And that'll change a lot of things. Requeen changes a lot. But Victor, do anybody have any questions of me?
4:47.
Okay. Anybody got any questions of me?
We don't have anything on chat.
There's no chat. Yes, sir. Talk to me.
That was something, but did you?
That decide what?
Which?
Textbook.
She'll make sure.
Ara, are you talking about? Ara.
She had a conversation with me about that after the last meeting. So many things went on, but it's really my fault. Gotta get back. You have a particular institute. They all pretty much say the same thing. Whatever you. I'm gonna look for something that makes sense. I'll get you a book like that. That's gonna make Aaron mad because we're talking about food. Got you done.
Yes, she's right here. She says, I'm here.
But no, what we'll do, we got one first lessons. We may look at that. Let me go ahead and do that. Just how much. The way we're gonna go into this, but I can promise you before the next class, that list will be out. All right. Got anything that make me seem like I'm smart? You wanna ask me a question? But look, I thank everybody that came on Zoom. I think everybody that came by. These guys like adults, they're available. And that's why I want to bring, a lot of us talk about costs and everything, gas going up and all this stuff. That's why I wanted to bring these things out on cost, because beekeeping is not an inexpensive hobby. If you put your money in that hive, you put your money, the bees, all this stuff, the bee clothes, all this stuff, you need to know what's available to you, how you can be helped. That's why groups like this and everything work out, because those are different things that we need to help each other. And one of the things I like to say, and everybody else like to say, and I didn't get to say it today, I'm having a good time, and there's more than one way to rob. What I mean by that is, what might work for me may not work for you. Don't make anybody wrong. All we doing is trying to help each other get through it. For as long as you're not having them.
So that's it.
Yes, that's it.
Okay, everyone. Does anybody have any questions out there in Zoom land? Any questions from anyone? If not, we're going to be logging off and y'all can log.
I have one question. When will you be making the?
I know it's a little rough go at first, but we got it together. It took us a minute, but we got it together.
I'm not gonna say what.
China, I have a question.
We special.
Can you hear me? Hello?
Okay, all right. Thanks, y'all. Well, the next class will be in 2 weeks.
You had a question.
Yeah, I was trying to ask the question. I don't think you could hear
Yeah, the
me.
second Thursday in July, whatever that date is. So, but anyway, someone's trying to ask a question. Okay. Who is trying to ask a question?
Jakeisha, me.
Hey, Jakeisha, I can't hear you, babe.
I don't know why. I can hear you and everyone else I think can, and someone else heard me.
She is. Put it in the chat if need be, Jakeisha.
It's just, okay,
I
that's,
said, I can't hear you, baby. I don't know why. Yeah, we see the audio, but
someone says they can hear me, so I
for
would ask.
some reason, your voice is not coming through.
We can hear.
Oh, you know what? Hold on. It's probably because. All right, go, baby. Go ahead.
I typed now. It
Oh,
was like,
Google file folder for the presentation.
yes,
today.
that's all I was trying to ask, if someone could send the link, and I still need the application.
Okay. Barry's gonna be we gonna work all of that, and I've got my little.
I'll get with you on that and about dues and application and everything else, okay?
All right, just want to make sure I'm claiming it correctly. I don't want to put it on paper saying I'm a part of a club and I haven't paid dues.
I heard you, okay?
Yeah.
Don't worry about that.
And Ara just said that she can send the folder out. So that was just said in the chat. So there we go. Any
Okay.
other? You're welcome, baby.
Make sure you, make sure you, on that. With Rapid USA, asked about it, today, he sent me a text, did he?
No.
Okay, he asked about that, you want to get the last class that,
And we will get everything updated there soon. We just had, we ran into some things.
Administrative things that get about channel, error about, we'll handle that, but I'm gonna let everybody else go because like I said, these are the matters we do to handle on. Thanks for coming.
All right, y'all have a good one. And we will see one other the 14th of July. The 14th of July.
Between 3 and 5.
Yep, the
We're gonna
14th.
complete, we're gonna send you the year-round beekeeping. And then we're gonna, that's what the next class is gonna be on, year-round beekeeping.
Year-round beekeeping, July 14th. All right, everyone. I'm getting ready to shut it down, Barry. Bye, y'all.
Bye.